Entities in Cloud Data Store form a hierarchically structured space similar to the directory structure of a file system. When you create an entity, you can optionally specify another entity as its parent. The new entity is a child of the parent entity. An entity without a parent is a root entity. An entity's parent, the parent's parent, and so on are its ancestors. An entity's child, the child's child, and so on are descendants. The sequence of entities from the root entity to a specific entity forms the ancestor path. For example, entity John Doe of the customer kind is the root entity. The complete key for the pencil entity includes the kind identifier pairs customer John Doe, invoice June, and the pencil entity itself. For more information about entities, properties, and keys, see the link here. To support queries on non-key attributes, Amazon DynamoDB allows you to define global secondary indexes on a table. You can specify any of the non-key attributes as the partition key for the index. You can optionally specify a sort key as well. You might need to query on a different sort key than the table's sort key. Amazon DynamoDB allows you to set up local secondary indexes for this use case. The local secondary index shares the read and write throughput settings with the table. Cloud Data Store automatically creates indexes for each property of each entity kind. These built-in indexes are useful for simple queries. You can optionally exclude indexes on certain properties if you are unlikely to query using those properties to save space. Composite indexes in Cloud Data Store index multiple property values per indexed entity. Composite indexes support complex queries. To support ancestor queries, the index may also optionally include an entity's ancestors. An ancestor query limits its results to the specified entity and its descendants. Consider the example of a customer service table in DynamoDB. Customer ID is the partition key and date of service is the sort key. Support rep ID and description are the other attributes in the table. With this structure, you can query all support calls for a customer or all support calls for a customer in a particular date range. To query support calls for a customer and a particular support rep, you can set up a local secondary index with customer ID as the partition key and support rep ID as the sort key. To query the days on which a support rep worked on issues, you need to set up a global secondary index with support rep ID as the partition key and date of service as the sort key. DynamoDB allows you to create indexes with exactly two key components, a partition key and a sort key. Consider the same customer service information as a Cloud Data Store entity kind. In Cloud Data Store, you can specify an auto-generated key for entities of this kind. Cloud Data Store automatically creates built-in indexes for the other properties in this kind. This enables you to execute simple queries such as querying all support calls for a particular customer, for a date, or a support rep ID. You can also omit indexes for certain properties such as description. Using the built-in indexes, you can even query with complex filters. For example, you can query for a particular customer ID and support ID combination. No additional indexes are needed. A key difference between DynamoDB and Cloud Data Store is that you can create a composite index on more than two properties. For example, to query if a particular support rep, John, was busy with the customer Jane between March 1 and March 31, you can create a composite index on support rep ID, date of service, and customer ID properties. This capability enables you to run queries with more complex filters. For more information about indexes, see the link here.